Hello, my dear students. My name is Dr. Amit Tomar. I am Senior Assistant Professor in Department of Physics and Astronomical Sciences, Central University of Jammu campus. Jammu campus. Today, I am here to present a video lecture on your regarding your entrance examination in CUET in physics. Today, I am here to present a very important lecture. The topic of my lecture is electromagnetic spectrum or electromagnetic wave. So let's start. Here is the first PPT regarding introduction of electromagnetic wave. Here is some important points. So we are going to read one by one and explain in a very classically so that you may understand what we are going to tell you regarding electromagnetic wave. So first point, electromagnetic wave are wave that consist of oscillating electric and magnetic field which are perpendicular to each other and the direction of propagation of wave. So what does it mean? This is a very important point regarding the cause of origin of electromagnetic wave and how the electromagnetic wave originates in nature. So as you see here, the words we have used oscillating electric and magnetic field. What does it mean? Oscillating electric field, oscillating magnetic field means the electric field is a time dependent, the magnetic field is time dependent, and the cause of electric and magnetic field uh, origination is the charge which are accelerating in motion. So the electric field produced by the charge which are in rest or maybe moving. But here the electric field produced by the accelerating charge. That's why we use the word oscillating electric field and oscillating magnetic field. So the time dependent electric and time dependent magnetic field are responsible to produce the electromagnetic wave when these are perpendicular to each other, and these two uh, quantities, electric field and magnetic field, are perpendicular to the direction of propagation of the wave. So keep that in mind. This is a very important definition of electromagnetic wave, that the direction of propagation, in which direction basically wave propagates or wave moves. This is the direction of propagation. The direction of electric field and direction of magnetic field are all three perpendicular to each other. In other words, if electric field is in the x direction, then magnetic field may or may not be in a y direction, and the wave propagate in the z direction. No no one of the any two parameter in between these series in the same direction. So the condition of forming or the condition of originates the electromagnetic wave in nature is that the electric field, the magnetic field, and the direction of propagation are both perpendicular to each other. If electric field in x direction, magnetic field in y direction, then wave propagates in z direction. Or this is only an example. The direction may be interchange, maybe wave propagate in y direction, electric field in the x direction. The basic point is that these all three are perpendicular to each other. The second point is that the electric field and magnetic field are in the same phase. Besides, they are perpendicular or 90 degree to each other, but they are in the same phase. There is no phase angle between them. So these are the three important points for the formation of electromagnetic wave, or the wave which have the property of electromagnetic in nature. The wave should have their the wave should have their oscillating. The oscillating word is very important. Keep that in mind. Oscillating means time dependent electric field. So electric field, magnetic field, and direction of propagation are all three quantities perpendicular to each other. So this is the basic definition of electromagnetic wave, and it is the basic definition of the transverse wave also. So what does it mean? The electromagnetic wave is transverse in nature or character. So transverse wave is that wave which have electric field, magnetic field, and direction of propagation. All three are perpendicular to each other. In nature, as we know, sound wave is a longitudinal wave. So electromagnetic wave is the transverse in nature. So I think I have spent lots of time on the basic theory of electromagnetic wave and how does it originates in nature. In nature by sun rays. Basically, sun rays is the electromagnetic wave. In naturally they comes from the sun, but experimentally by the instruments we have are in the position to originate the waves in the laboratory also. So its nature, the nature of the electromagnetic wave is that they doesn't require any medium to travel. They easily travel in vacuum. Besides the sound wave, which requires the medium to travel. So electromagnetic wave is a very special property, and as we know, sun rays comes from the space and travel through the vacuum. The speed of light is a very good constant and parameter, and its value is 3 into 10 raised to power 8 meter per second. It is constant, and no wave in the nature can exist with the speed greater than that of speed of light. So it is the limit of the speed. No particle in nature which can travel the speed much more than the speed of light. And if any particle is traveling the speed much more than the speed of light, then they are not fall in the category of the particle. These two statements are equivalent. So this is the limit or this is the maximum speed which is available to achieve by anyone in the universe or in the nature. Some examples here: light wave, radio wave, X-rays, microwave are some common example of electromagnetic wave. The number is much more. Here is the some basic examples. So let's move further. These are some characteristics of electromagnetic wave. So here we have start with the speed. We have already discussed. The thing important here is that the speed of light, which we have read 3 into 10 raised to power 8 meter per second, is the maximum speed achieved by the electromagnetic wave in free space. If the electromagnetic wave travels inside the material or the medium, this may decrease accordingly. So again, we don't require any medium. It doesn't mean that electromagnetic wave doesn't propagate inside the material or the medium, but it don't require any medium. In medium, it may also propagate, but the speed decrease accordingly. Unlike to the sound waves, which always travel through the medium and doesn't travel without the medium. Again, the transverse nature, as we have already discussed, the electric field, the magnetic field are perpendicular to each other, but you have to keep in mind always the electric field here are the electric field which originates from the charge which are not stationary, which are not in the rest position. Stationary charge, the charge which are in the rest are always produce electric field. But here the electric field produced by the charges which are accelerating in motion. Here is the magnetic field which is produced by the oscillating currents. So keep that in mind. It is the accelerating charge which is the basic point or the point where we have to start to originate the electromagnetic wave. So these are the time dependent electric and magnetic field. These are the not stationary field. These are the not stationary magnetic field. So electric field, oscillating magnetic field are perpendicular to the direction of propagation of the wave. And when this condition is satisfied, so the wave comes out to be in the form of the transverse in nature or the wave nomenclature is electromagnetic wave. So electromagnetic wave is a wave in which the direction of propagation, the direction of the electric field, the direction of the magnetic field, all three are perpendicular to each other, and electric field and magnetic field are in the same phase. Keep that in mind. This question asked again and again in so many competition that what is the phase difference electric field and magnetic field in electromagnetic wave. So they are in the same phase. But if anyone asks, what is the angle between the direction of the electric and magnetic field and direction of propagation also, then it is 90 degree to each other. But the phases, they are in the same phase. So in regarding to the phase, electric field and magnetic field are in the same phase, but they are perpendicular to each other. This is some confusing creating statement. Some student reads they are 90 degree to each other, so maybe they are 90-degree phase difference. So keep that in mind. The phase difference between electric field and magnetic field are 0 degree. They are in the same phase, but angle between them is 90 degree, and also the direction of propagation. So all three, direction of propagation, direction of magnetic field, and direction of electric field, are all three in perpendicular to each other. This is very important point for wave to have the transverse in nature and to call nomenclature electromagnetic in nature. So hope you perfectly understand what is electromagnetic wave and what is transverse wave. So again, the very important quality, the energy transmission is a very important property, because electromagnetic wave may transfer, may carry energy and momentum with them. As you know, sun rays, we have feel sun rays, we have feel a hotness when we sit in the sun bath or in sun rays. So this is directly you may interact, that carry energy and momentum. Again, the last point is the frequency and wavelength relationships. What does it mean? Basically, frequency is directly proportional to the energy. If we may say that any wave have a high frequency, then it means that this wave is a very high energy. But in terms of the wavelength, as we know, wavelength is inversely proportional to the wavelength. So any wave have a high energy, may have a high frequency, but the wavelength should be low. So if any wave have a high frequency, then the wavelength is low. So this is the relationships between these three. So this is PPT regarding some components of electromagnetic wave. Again, the electric field oscillates in a plane perpendicular to the direction of propagation. That is the perpendicular relationships between all three, direction of propagation, direction of electric field, direction of magnetic field. Basically, electric vector is known as the light vector, and it is the electric vector or electric field which is responsible for the all optical property of the electromagnetic wave and influences the charge particle. It is not the magnetic field. Here again a question arises. It is the electric field which is responsible for all optical property of the electromagnetic field, not the magnetic field. Again, the oscillating magnetic field oscillates in a plane perpendicular to both electric and direction of propagation to make all three perpendicular to each other to satisfy the condition of transverse in nature character. Basically, the wave propagation direction, you know, the energy is always transmitted in the direction of the propagation of the wave. Let us say, by example, if wave propagates in x direction, then energy is also transmitted in the x direction, and maybe electric field in the y direction or z direction, and accordingly magnetic field in the x direction or z direction, under condition all three are perpendicular to each other. So energy is always transmitted in the same direction in which the electromagnetic wave propagates. So energy transfer direction is always perpendicular to both electric field and magnetic field. So this is again a relationships between electric field and magnetic field, and we have already discussed it. These all three are perpendicular to each other. Electromagnetic spectrum overview. Basically, electromagnetic spectrum means it is a bundle of waves. It is not a single wave. or it is a collection of large number of waves, and individually these waves are known as radio waves, microwave, infrared wave, ultraviolet wave, is X-rays or gamma rays. So what we want to say, we say that electromagnetic spectrum is a collection of different type of rays which characterize according to their wavelength or frequency, so that we may easily remember or easily nominate their name according to their wavelength or frequency. So here we are going to the longest to the shortest wavelength in term of wavelength. So radio wave is the wave which have the highest wavelength among all the electromagnetic spectrum, or among all the electromagnetic waves available in nature. Radio wave is the highest wavelength, and because of this property, the highest wavelength, it may have the certain application which itself very important in current generation and for the next generation. So next is the microwave, and after microwave we have the infrared wave, we have the visible light, and visible light itself have a bundle or collections of some light like blue, green, violet, red. So after that the ultraviolet and X-ray, and lastly the gamma ray, the lowest wavelength, but gamma ray have the lowest wavelength but highest energy or frequency. So in other words, if we want to tell you that in term of frequency, so the gamma rays is the highest frequency and the radio wave is the lowest frequency. And in term of wavelength, radio wave is the highest wavelength and gamma rays is the lowest wavelength. So these nomenclature are according to their wavelength or their frequency, so that we easily understand by which we may use as per their applications or their characteristics. So, visible light is a small portion of the spectrum detectable by the human eyes. It is the only light which we have seen, or some other way which we have feel, like infrared. We have feel the sensation, and infrared rays are also emitted by human bodies. And as we know, the infrared photography we have used in the night. This is a very special property of infrared wave, by which we may build a special class of cameras for night vision photography. This is only because of the special property of infrared waves. Okay. So in term of visible light, the red color is the longest wavelength and violet is the shortest one. In term of frequency, violet is the highest energy and red is the lowest energy. So only because of that, as you have seen the red signal light in the traffic or railway tracks, it is the longest wavelength. So we have see it from the large distance and make the precaution. So this is the only reason why we use red light, only because the longest wavelength which we have seen from the far distance. If the violet, then we have used violet, but here red is the longest wavelength. That's why we have used it. Okay. Now application, as per their characteristics property, we have used some rays in a communication. We have used some rays for the medical imaging and etc. etc. Now move further. Now radio wave. Now radio wave are basically a special kind of wave. Now we are going to treat them individually regarding your competitive examination. So radio wave is a wave which have the longest wavelength, or or longest wavelength, or minimum frequency. So as you know, the radio wave have the longest wavelength, and only because of the special property, we use radio wave for radio transmission, receiving signal, telecommunication, transferring signal here and there. And you see on the television, mobile phones, and FM radio, these all instruments use radio wave. I am giving a lecture in my room and you listen my lecture on your mobile phone and laptop also. then this my voice just the power to communicate in a room inside. But you have listened so many far distance from my place. How is it possible? It is possible by the few applications of modulation and demodulation. These are the two process that by which the my voice signal, it is a signal, and to combine these signals with or adding these signals with radio wave, and radio waves may travel the so many distance because of their very large wavelength, and at the place where we want to receive, we demodulate the signal and the wave, and we may receive the signal in their original form. This is the main application of the radio wave. They may transfer your voice, your message along with the wave, and at the place where you want to listen, then at that place you may demodulate them. So in next PPT we have show you the instrument regarding this. So there is some property, radio wave can travel long distance and penetrate through obstacle like building and the atmosphere. This is the reason why we use in the communications. They are reflected by the ionosphere. Ionosphere is the uppermost layer where they are enabling long range communication. So some basic uses are FM radio, AM radio, television broadcasting, mobile phones, navigations में GPS and radar systems. In astronomical telescope, we have used the radio wave. This is very important question asked so many times. Which electromagnetic wave in radio telescopes? A radio telescope or may in astronomical purpose. So this is the radio wave which is used for the astronomical purpose to studying the distance object in space or galaxies. So basically, electromagnetic wave range from 3 kilohertz to 300 gigahertz. This is a range, and the waves which lies between them are radio waves. So we move further. So these the setup. So as I speak from my mouth and generate the some signal, some message in the lecture form on my speaker, then my speaker catch it, and this modulate with the radio wave, and amplifier increase the amplitude of the radio wave, and somewhere large distance travel. This is the message which is resides with the radio wave and travel a very long distance and may receive at the receiving station, and then the instruments demodulated the wave and just rectify the message, which is my lecture or song, whatever you listen. And this is the main application of the radio waves to transfer the signal or message at the large distances. So hope you understand what I want to say. Now this is the PPT regarding microwave and other individual electromagnetic wave. The frequency range from 300 megahertz to 300 gigahertz. Or it is also the shorter than the radio wave in the wavelength. So travels in the straight lines and are less affected by the atmosphere as compared to the radio wave. Can penetrate through clouds, smoke, and light rains, making them ideal for certain applications. We may use for satellite purpose, mobile networking, and very especially in Wi-Fi and Bluetooth. So in some competition, if anyone asks which type of electromagnetic wave you use when you open your Wi-Fi in your phone, or when you connect your Bluetooth speaker to your phone or your car, then you may use the microwave, or microwave is the responsible for transferring the data in Wi-Fi and Bluetooth. So keep that in mind. It is the microwave which is responsible to transfer data by Bluetooth and Wi-Fi or Bluetooth, right? When you're sending the signal in a very short distance, but for long distance, which may be several kilometer to hundreds kilometer. So this is the radio wave, not microwave, but to a very short extent. So this is the microwave, which is good. As you know, in every kitchen we have a microwave, and this is The use of microwave is to heat the food because microwave have a special property to make the to produce the heat inside the layer. So no other wave have this property to generate the heat inside the layer. So in radar we have the uh, basically detecting the objects, their velocity, aviation, weather forecasting, and some defense purpose also. So basically, Wi-Fi network typically operate at 2.4 gigahertz to 5 gigahertz. So microwave is ideal in this range. So there is some basic setup regarding microwaves. Now infrared wave. Infrared waves are very nice way regarding next generation or current generation updated photography purpose in night vision. So basically the range from 700 nanometer to 1 nanometer and frequencies lies between microwaves and visible light. So some basic properties are emitted, infrared wave are emitted by all objects based on their temperature. This is very important. So here we, as I told you that human beings are also emitted infrared wave, and by detecting the infrared wave, we may capture the picture. So this is a technology which is used to produce the night vision photography in forest by photographer or for defense. This is very important to detect the enemies by capturing their infrared signal, or as you know, they are very good infrared thermometer, which we have used in COVID times, in airports, in bulk, when mass comes and is it not possible to measure individually touching them the temperature. So how do you differentiate peoples from their temperature? Then infrared sensor thermometers are capture their infrared which is emitted by the body, and then we find the temperature and point out them that you are a fever and you have not fever, your body temperature is normal. So this is very nice technology which we have used during COVID time also. This is very nice uh, uses of infrared in the thermometer and infrared sensors. Basically, this is the only way which human may radiates from its body. This is a simple setup regarding infrared. So move further. Now, visible light is a very uh, familiar one which we all have in daily life part. So we have the range 400 nanometer to 700 nanometer. So maximum wavelength is the red light and minimum wavelength is the violet light in the visible spectrum. So frequency lies between infrared and ultraviolet waves. So basically, this is the only part of the electromagnetic wave which we have seen from our eyes. The colors basically are 7-1, red, orange, yellow. You all know very well. So basically, infrared are also just very close to red, but we not see by my eyes, but we may feel by the heating effect. So these are the visible light property and uses. So basically, some most common uses are photographic optical device where we directly see in the picture. So as we see the most common example is the rainbow. So here need not to discuss much more about visible light. These are the setup when we pass visible light or white light. Basically, white light consists of the 7 colors. So when we pass it from the prism, then all color are seen individually. So this is very common example. Now the ultraviolet waves. Again, a very important components of the electromagnetic spectrum, ranging from 10 nanometer to 400 nanometer. So its frequency lies just above visible light and just below the X-ray. Some properties of basically, as we know, this is invisible to human eye, but can affect certain material, causing fluorescence. Basically, fluorescence is the property when the uh, you incident a light on the material, and by the effect of the incident light or radiation, better way you may say the radiation, so that material glows and you may detect the invisible or hidden material. So this property is very nicely utilized by the airport authorities, and when they incident the ultraviolet rays, so some material glows and they capture the material which is not allowed during your transport on the aeroplane. So for security purpose, this is a very good. So higher energy than the visible light, so it may harmful your skin. So basically, sun rays is the primary source of the natural UV radiation. So we may take umbrella or some kind of protection during direct long-term sun ray. So it may affect our skin if the sun rays contain large amount of UV radiation. So UV radiation is harmful for our skin. If anyone want to expose industrial purpose some more time in UV radiation, so they may take care about their bodies so that some clothes or protection must be taken. The uses is very important in term of forensic science. That is fingerprint detection, UV sensitive material that we have discussed regarding fluorescence. Some instruments, some materials are very sensitive to UV rays. When we incident the UV rays to that material, then they immediately glow and we may capture. So this is the main use of the UV rays, and basically some identity cards and other digital electronics may have some use of ultraviolet wave. As per our need, as per our generation applications, the use may be vary number. So number may be much more, but here we have some common examples. Now this is the primary setup of ultraviolet wave by the sun. Now the very important wave, the X-ray. This is the one of the most very important in our daily life, medical science, and we may say that X-ray is the one of the most important component of the electromagnetic spectrum in point of view medical line. So the frequency ranging from zero point zero 0.01 nanometer to 10 nanometer, basically higher than ultraviolet waves and very high energy X-ray contains. Some properties, it may easily penetrate the soft tissue but are absorbed by the denser material like bones. So basically X-ray are not penetrate inside the bones but penetrate inside the skin. So this is the main difference. So if you want to make to know whether which bone is fractured, it is important. But inside the bone, it may does enter. It doesn't enter. So it may cause ionization. Ionization means when we incident the X-ray on a metal, then it may detach the electron from the atom, and atom may the ionize. So this is very important, and it may damage tissue also, and it is not very good for your health to expose your body in long term in X-ray containing environment. So the main use of X-ray in the body imaging for knowing the disease and dental cavity inspection. So in industry, they are also inspecting the metal welds and structure of cracks and defects. So X-ray we have used in the medical purpose and medical line. So this is the most common example of X-rays. Now, last one is the gamma rays. The frequency in the range of zero point zero 0.01 nanometer, and it is the highest and extremely high frequency and high energy rays. These are the energy parameter which is responsible to penetrate the obstacle, and as you know the gamma rays is the highest energy, so it is the most penetrating rays among all the electromagnetic spectrum. So it may penetrate through the lead sheet, aluminum sheet. It may emit during the nuclear radiation. That's why it is most dangerous. It may ionize the atoms, damage your cells. Some basic treatments in the medical line to target to kill the cancer cells. But the bad effect is that these are used to kill the cancer cells, but some good cells may also kill by these treatments. So cancer treatments is helpful also, but dangerous also. So effects positive and negative both together. So for astronomical purpose, gamma ray telescope is one of the most important telescope regarding space travel while sitting on the Earth. So to know more about supernova, black holes, so we need a very high energy telescope among the radio telescope and combine these two effects and we generate the very good telescope. So this is basically some uses of the gamma rays. The cancer treatment by the gamma rays, such as cobalt 60, with the help of cobalt 60, one of the very important uses. So gamma ray are used in the treatment of cancer, and basically some PET scan also use gamma rays. So some medical uses here. Now we move further. There is a setup basically how gamma ray penetrate in human body in thin aluminum sheet, thin lead sheet. But the important thing is that it doesn't penetrate the water. That's why the reason we use water in all reactors so that they may not transfer these hard rays in the outside the atmosphere. So that in reactors where we generate these rays, we use the water as a user obstacle so that they may not penetrate through the water. So water is the very important uses regarding obstacle in the penetration of the radiation. Basically, three electromagnetic wave, gamma rays, X-rays, and ultraviolet wave, commonly known as radiations. Radiation means high energy rays. So these are some overviews regarding electromagnetic spectrum. Basically, electromagnetic spectrum, their relation between wavelength and frequency, some key point we have in this PPT. Electromagnetic wave is basically we have characterized all electromagnetic wave according to their frequency, according to their wavelength. As you see, the highest wavelength wave is known as radio wave, the lowest wavelength is known as gamma wave. I mentioned these two because these two are the limiting case of the electromagnetic wave, and we have the much more number in between them like microwave, infrared wave, and visible wave. The relationship between electric field and magnetic field you know very well. The longest frequency, the longest wavelength, now you better understand. As you know, the wavelength has the inverse relation with the frequency. So as frequency increases, wavelength decreases, or wavelength increases, frequency decreases. Some key points: radio waves, we have a longest wavelength and lowest energy. For gamma rays, we have shortest wavelength and highest energy. Visible light is the only part of the bundle of the electromagnetic spectrum which we have see from our eyes. Other electromagnetic wave we have feel by the sensation in our body, and infrared wave is the wave only emitted by our body in corresponding to the our body temperature. So there is some application of electromagnetic wave in term of communication. We have used radio wave in AM and FM radio broadcasting, in TV signals, and in long term communication in satellite phones. We use radio waves. Microwave essentially for mobile network, for satellite communication, and you know very well Wi Fi and Bluetooth purpose. The wave responsible are microwaves. Infrared wave we have used in the for in a hot case to make hot our food and to night vision photography. This is the very common use of infrared Cameras are very important in current generation scenario for defense also. Defense person also use infrared photography. So visible light fiber optics use these light signal to transmit data over long distance at high speed. So here is some medical applications, as you know very well, the X-ray, the use of medical imaging, detection of some dental problem, dental fractures also, and gamma ray for the treatment of kill the cancer cells, and infrared for detection the inflammation regarding body temperature creation, and then you collect the infrared and keep positioning the where is the that body which sending these waves. So here is some again application of electromagnetic wave. So we don't need to discuss much more regarding their security purpose, their scientific purpose. We have already discussed very detailed applications. So these again some safety and precautions with electromagnetic wave. So as we have told in early PPT, like you have to avoid the long-term presence of your body in X-ray, in UV, and in gamma ray. So this may damage your skin cells and may cause the cancer in your body. So keep that in mind. If you have to work for a long time, then take precaution. Some materials which are very useful to keep away these rays from your body. So again, some PPT regarding your safety precaution. So we have already discussed. So now these are the last session on my lecture, and this is very important lecture regarding your examination. So one by one, we have discussed all question and discuss their answer. Which of the following electromagnetic wave has the longest wavelength? So the option is X-ray, radio wave, ultraviolet rays, and infrared. We have discussed the radio wave is the longest wavelength, and gamma rays is the smallest wavelength. But in term of answer, if we change the question, which of the following electromagnetic wave has the shortest wavelength? So what is your answer? Then your answer is the think in your mind. If we have the gamma rays, then answer should be gamma rays. But we don't have gamma, so the answer is the ultra rays. But in the in context of the following question, the answer is the radio waves. So keep that in mind. Like when we read the question in term of longest wavelength, immediately you think about the slowest wavelengths or even high energy or high frequency. What is the speed of electromagnetic wave in vacuum? So you know very well it is speed of light, and the answer is 3 into 10 raised to power 8 meter per second. It is the highest limit in nature. The rate may be achieved. No one can achieve the speed greater than this limit. So now, which of the following is not a property of electromagnetic wave? The wave can travel through a vacuum. They require a medium to propagate. They are transverse wave. They consist of oscillating electric and magnetic field. So answer is very clear. They required a medium to propagate. So if such type of questions come, so here you should underline the not. So not in hurry, just take your time. And the question is which of the following is not. So all three are the property of electromagnetic wave, and this one is not the property. They required a medium, they doesn't require any medium to propagate. Which electromagnetic wave is used in night vision goggles? So you know very well, this is the infrared. So which part of the electromagnetic spectrum is visible to the human eye? Answer is very simple, it is the visible light. Now, which type of electromagnetic wave is used to sterilizing the medical equipments? So the answer is gamma rays. Now again, what happens to the frequency of electromagnetic wave as the wavelength decreases? You know very well the wavelength has the inverse relation with the frequency. So if wavelength decreases, frequency increases, and if wavelength increases, frequency decreases. So answer is the C option. Now, which electromagnetic wave are primarily used in mobile communication? The answer is microwaves. What is the primary use of ultraviolet rays in daily life? So, as you know, the cooking food is responsible for the microwave in your kitchen. So, detecting conflict currency is the right answer. And the last one is which of the following correctly matches the waves and its application? So, X ray for medical imaging, and radio wave for radiation therapy, microwave for studying stars, gamma rays for cooking. You know very well, microwave for cooking, X-ray or medical imaging is the right answer. So radio wave for radiation therapy, this is wrong. You know radiation therapy by gamma or ultraviolet maybe, and B option is the correct. So here today we ends my lecture. Hope you write my hope you like my lecture, and I want to cover all the points in a very nice way in question and answer. And keep watching my lecture to know more about physics in CUET. So, wish you all very best of lucks regarding your exams. Hope you enjoy my today lecture.